A sweeping shot of the Milky Way galaxy slowly zooms in toward a small yellow star. The camera keeps zooming in until it's close to one of the star's orbiting planets. Then it zooms in again, revealing a tiny blue world shining faintly in the darkness. Narrator. Among billions of galaxies, each containing billions of stars, there exists one small, fragile world where oceans ripple, forests breathe, and life contemplates the cosmos itself. That world is Earth. But why here? Why not on the countless other planets scattered across the universe? Why has Earth, of all places, become the cradle of life? Scientists call this delicate balance the Goldilocks principle. The idea that our planet is just right for life, not too hot, not too cold, not too big, not too small, positioned in precisely the right cosmic conditions to nurture biology, complexity, and intelligence. Yet this balance is far from simple. Each factor, from the warmth of our sun to the chemistry of our atmosphere to the architecture of our galaxy, plays a role in shaping the destiny of Earth. It is a cosmic lottery win, one that has allowed us to ask the very question, why are we here? In this documentary, we'll explore the hidden science behind Earth's uniqueness, its position in the solar system, the chemistry of life, the role of the moon, the shielding of Jupiter, and the cosmic coincidences that made this planet a home. This is the story of how Earth won the cosmic lottery, and what it means for life beyond our world. Goldilocks and the Three Bears is obviously the story that inspired the term just right. In the tale, a girl sneaks into the house of a family of bears. To find somewhere to sleep, she tests each item in the bears' home, like their chairs, beds, and mattresses. Each time she tests an object, she chooses the middle option, which is just right for her. And it's the same with the conditions for life. Let's start with the temperature. If our sun were just 20% hotter, Earth would be a scorched desert. If it were 20% cooler, Earth would be a frozen wasteland. As it is, the sun sits in the middle of a range of temperatures suitable for life as we know it. At about 4.4 billion years old, our sun is also in the middle of its life cycle. Stars that form today will likely not reach their habitable zone for several million years, while stars that are older might have life-giving potential for a few billion more years. We are here at just the right time. But it's not just our place around the sun that makes Earth habitable. Earth itself must also be just right. Our planet is in the middle of the solar system. Big, gassy planets like Jupiter and Neptune are further out, and scorched, barren worlds like Mercury and Venus are closer in. This means that Earth doesn't have to worry about being too cold or too hot, too big or too small, too close or too far away. And Earth is also just right for chemistry. Water is essential to life as we know it. And water is only liquid at the temperatures found here. Any hotter or colder, and it would exist in a different state, like a gas or a solid. Other elements needed by living things like oxygen, nitrogen, and carbon are also only found in the quantities we need here. Earth's atmosphere is also just right. It contains the right amount of oxygen for us to breathe and carbon dioxide to keep our climate stable. Even the level of radiation from the sun is just right for life. Too much, and our planet's surface would be a lethal desert. Too little, and life could not evolve because Earth would be shrouded in an ice cap. And it's not just our solar system that's just right. The architecture of our galaxy also plays a role. The spiral arms of the Milky Way contain the most densely packed stars. It's here where Earth finds itself, nestled in the galactic habitable zone. Outside the arms, there are fewer heavy elements, making it difficult for life to evolve. Inside the arms, there is so much dust and gas that it would be hard for life to emerge. We are in the middle of the galactic habitable zone. Our planetary system also benefits from the protection of the giant gas planet Jupiter. Its gravity pulls in many comets and asteroids that might otherwise smash into Earth. Some scientists even believe that Jupiter's gravity helped Earth capture the moon, which stabilizes our planet's tilt and nurtures life. In fact, so many factors have had to align for life to flourish on Earth that some scientists have dubbed it the Great Filter. Just as Goldilocks chose the middle option in each test, life seems to require a middle option in each variable. Being in the middle of the Milky Way, in the middle of the solar system, the middle-aged star that is the middle option in size and temperature, a planet that is the middle option in size and temperature. an atmosphere that has the middle option of gases in the right quantities, and chemical building blocks that exist in the middle range of states, not too much, not too little. Over billions of years, Earth has moved in and out of the habitable zone during ice ages and warm periods, but overall, our planet has stayed in the middle. So Earth is indeed a cosmic lottery winner. For life to emerge and thrive, so many factors need to be just right. With odds so astronomical, why should we expect life anywhere else? Perhaps we are truly alone in the universe, or perhaps life really does arise wherever conditions are just right. Do you think there's life elsewhere in the universe? Let us know your thoughts. The discovery of thousands of exoplanets has taught us two things. One, that planetary systems are incredibly diverse. And two, that ours looks pretty ordinary. But while the everyday wonders of Earth seem almost boring compared to alien worlds, our planet's normalcy is actually its specialness. Because what seems mundane is in fact a unique combination of circumstances that came together to make Earth a home for life. From its position in the solar system to the atmospheric balance that makes rain and wind, every aspect of Earth works together to sustain the biosphere. In some ways, we're living on a cosmic lottery ticket. So to understand why Earth is so extraordinary, we need to begin with the basics. What do scientists mean when they say our world is in the Goldilocks zone? The term comes from the children's story of Goldilocks and the Three Bears. Goldilocks doesn't want porridge that's too hot or too cold. She wants it just right. In astronomy, this phrase describes the habitable zone, the region around a star where temperatures allow liquid water to exist on a planet's surface. Water is not just a refreshing drink. It is the universal solvent, the foundation of all known biology. Every cell on Earth relies on liquid water to transport nutrients, remove waste, and power the chemistry of life. Without it, life as we know it simply cannot exist. So, where a planet lies in relation to its star becomes the first and most obvious requirement for life. If Earth were only a little closer to the Sun, our oceans might have boiled away like Venus. If it were just a little farther, it might be a frozen desert like Mars. Instead, Earth's orbit is perfectly situated in the middle of this habitable band. Not too hot, not too cold. But the Goldilocks principle goes much deeper than orbital distance. Temperature alone doesn't guarantee a living planet. Mars, for example, lies on the outer edge of our Sun's habitable zone. Billions of years ago, it had rivers and lakes. But today, it is barren, its thin atmosphere unable to hold on to warmth or liquid water. Venus, by contrast, is only slightly closer to the Sun than Earth. Yet its atmosphere is a runaway greenhouse, a suffocating blanket of carbon dioxide that has raised its surface temperatures to over 450 degrees Celsius, hot enough to melt lead. This tells us something critical. Being in the Goldilocks zone is necessary, but not sufficient. Life requires a whole orchestra of conditions working in harmony. Earth, somehow, has them all. Let us list just a few of the key players. The right star. Our Sun is stable, long-lived, and not prone to violent flares that would strip atmospheres from nearby planets. Planetary size. Earth is massive enough to hold on to an atmosphere, but not so massive that it becomes a gas giant. Atmosphere and greenhouse balance. Our mix of nitrogen, oxygen, and trace gases creates just enough greenhouse effect to warm the planet, without triggering a Venus-like catastrophe. Plate tectonics. The movement of Earth's crust recycles carbon and stabilizes the climate over millions of years. Magnetic field. Generated by Earth's molten core, it shields us from deadly solar radiation. The moon's influence. Our unusually large moon stabilizes Earth's tilt, preventing chaotic swings in climate. Cosmic guardians. Even Jupiter, the giant of our solar system, plays a role by deflecting dangerous asteroids and comets that might otherwise wipe out life entirely. The Goldilocks principle, then, is not one rule. It's a web of interlocking conditions. A planetary recipe so rare and unlikely that, in a universe filled with trillions of worlds, Earth might truly be a jackpot winner. As we move deeper into this story, we'll see how each of these factors shaped our world and how fragile this balance really is. Because winning the cosmic lottery doesn't just mean luck. It also means living with the consequences of chance. Let's start with Earth's address. its location in the Milky Way galaxy. Astronomers often compare the galaxy to a city. At its center lies a supermassive black hole surrounded by densely packed stars. This is the galactic core, or downtown. Out past the core is a flat pancake-shaped region called the disk. Here is where most stars and planetary systems reside, including ours. In fact, Earth is about 2/3 of the way out from the center of the Milky Way, orbiting a star that is itself fairly average in size and age. On one hand, being in the middle of the galaxy gives us a galactic superpower, access to resources. The most important of these is the cosmic web, a vast network of hydrogen and helium filaments that spans billions of light years. Earth is essentially at the crossroads of this intergalactic highway. Over billions of years, the web has rained down fresh material, delivering everything from iron in our core to the building blocks of life itself. At the same time, our galactic location puts us in harm's way. The supermassive black hole at the heart of the Milky Way weighs in at 4 million times the mass of our Sun. Fortunately, it is not a threat to Earth. For one, our solar system orbits well outside its reach. Second, the Sun's gravity keeps Earth on a stable path around the galactic core. Finally, Jupiter, the largest planet in our solar system, acts like a bouncer, deflecting or destroying any wayward objects headed toward Earth. In other words, the galactic core provides sustenance and stability. But Earth is safe thanks to the gravitational influence of other players. Next up, let's zoom in on our cosmic backyard. Our solar system is dominated by one star, although it's just one of many systems in the neighborhood. There are hundreds of stars within just 20 light years of Earth. Being part of a community has its perks. As young stars formed from collapsing clouds of gas, they left behind debris that became the building blocks of rocky planets and gas giants. While no one star is special, the Sun is perfect for life. Stars shine by converting hydrogen to helium in their cores, releasing tremendous energy in the process. As a result, all stars emit powerful radiation that blasts outward, killing anything in its path. Young stars are volatile, prone to sudden bursts of energy and unstable jets of plasma. Our Sun is middle-aged, which means it is more stable and long-lived. Thanks to this stability, Earth receives a steady stream of energy that drives weather and climate. Moreover, the Sun's radiation interacts with Earth's atmosphere in a delicate balance that allows liquid water to exist. But there's more to stellar neighbors than just cosmic radiation. Stars like the Sun will spend less than 10 billion years burning through their hydrogen fuel. After that, they'll expand into red giants, engulfing nearby planets before being ejected from their solar system. Meanwhile, low-mass stars can live for trillions of years, quietly fading into white dwarfs. These stellar graveyards could become new homes for life after stars explode as supernova, blasting the universe with heavy elements like iron and uranium. These elements form the basis for biochemistry and play a key role in powering the engines of life. Meanwhile, the explosion ejects dust into space that forms the next generation of stars and planets. In short, Earth is in a cosmic nursery, receiving the raw materials for life from one stellar graveyard, while enjoying the steady energy of a middle-aged star. Finally, let's look at our cosmic address. Compared to other planetary systems, Earth's orbit around the Sun is highly stable. That's because the solar system is clear of objects that might destabilize orbits. Asteroid belts, usually found between Mars and Jupiter, are common in solar systems, but Earth's asteroid belt is sparse. The reason is simple. When Jupiter formed, its immense gravity cleared out the orbital path between Mars and Venus. Any leftover rocks and dust either crashed into Earth or were flung into the depths of the solar system. This means Earth is in a relatively safe neighborhood. Similarly, Kuiper belts are usually found at the outskirts of solar systems, but Earth's is non-existent. That's because Neptune's gravity extended inward, clearing out the region beyond the orbit of Mars. It's even thought that icy objects from this region once bombarded Earth, delivering water and organic molecules that jump-started life. In other words, Earth is at the sweet spot of a well-organized solar system. Its orbit is stable thanks to Jupiter and Neptune. Smaller bodies in the inner solar system cleared out the asteroid belt, leaving Earth free from bombardment. and the presence of these large gas giants created enough gravitational chaos to prevent Earth from ever forming an atmosphere-draining super-Earth. In conclusion, Earth's place in the cosmos is a matter of both fortune and good planning. Our world is in the habitable zone of a stable, long-lived star. It orbits in a quiet neighborhood protected by gas giants and peppered with asteroids that delivered water and organic molecules. But perhaps the most essential ingredient for life is the complex interaction of the systems themselves. For example, Jupiter's gravity prevents Earth from accumulating a runaway greenhouse effect like Venus, while the Moon's influence stabilizes Earth's axial tilt, which in turn produces a climate that's not too hot or too cold. Put simply, Earth is a Goldilocks planet because its conditions are perfectly calibrated for life. We often think of ourselves as the center of the universe, but the truth is, we're lucky to be alive. There is nothing special about Earth except that a unique set of circumstances aligned to create a world hospitable to life. Now watch how water on Earth changed our planet forever. There are billions of Earth-like planets out there, or so say the planet-hunting astronomers. But here on this pale blue dot, life not only exists, it's flourishing. What makes our world so special? This is the story of how Earth became the perfect planet. It started with a furnace. 4.5 billion years ago, our solar system was a swirling disk of gas and dust, the leftovers of ancient stars that had exploded in supernova. At its center, gravity pulled hydrogen together until nuclear fusion ignited. A star was born. Our sun. It may seem like an unremarkable event, but it wasn't. The sun is one of hundreds of billions of stars in the Milky Way. But what matters for life is what kind of star it is. The sun is classified as a G-type main sequence star, or yellow dwarf. That may sound ordinary, but it's exactly the right kind of ordinary. It burns steadily for billions of years, avoiding the wild instability of massive stars that explode quickly, or the dim faintness of smaller red dwarfs that often lash out with deadly flares. This stability gave Earth a long window of time, billions of years, to evolve complex life. Without it, the story of life would have ended before it began. Next came the Goldilocks event. As dust and rock in the protoplanetary disk clumped together, worlds began to form. Some grew enormous, becoming gas giants like Jupiter and Saturn. Others remained small, like Mars and Mercury. Earth found itself in the middle ground, large enough to hold a thick atmosphere, but not so large that crushing gravity would trap poisonous gases like hydrogen and methane. Our size also meant a molten core rich in iron and nickel, the dynamo that powers Earth's magnetic field. Without this invisible shield, the solar wind would strip away our atmosphere, leaving Earth a barren wasteland. So even before life began, Earth's very dimensions were setting the stage for habitability. But there was more to come. Next, there was the giant impact. Not long after Earth formed, catastrophe struck. An object the size of Mars, sometimes called Dea, collided with our young planet in a violent impact. The blast melted rock, tilted Earth's axis, and ejected debris into space. Out of this chaos, our moon was born. This event was more than cosmic violence. It was cosmic fortune. Earth's unusually large moon acts as a stabilizer. Without it, Earth's tilt would wobble chaotically, swinging climates from extremes of ice age to scorching heat. Instead, the moon's steadying pull keeps Earth's tilt at about 23.5 degrees. Stable enough for relatively mild and predictable seasons, this stability gave life the time and space to adapt and evolve, rather than being constantly reset by climate chaos. And then came the water. One of the greatest mysteries in planetary science is how Earth ended up with so much water. Was it delivered by icy comets? By asteroids from the outer solar system? Or was it locked deep in the planet's rocks from the beginning? Whatever the source, water was essential. Oceans moderated Earth's climate, absorbing heat and distributing it around the globe. They also became the cradle of life itself, providing a liquid medium for complex chemistry to unfold. Compared to our neighbors, Earth's watery fortune stands out starkly. Mars once had lakes, but lost them when its atmosphere thinned. Venus may once have had oceans too, but runaway greenhouse warming boiled them away. Only Earth has maintained its oceans for billions of years. A perfect balance of temperature, atmosphere, and gravity. Finally, there's Jupiter. Farther out in the solar system lies Jupiter, the colossus of planets. At more than 300 times Earth's mass, Jupiter's gravity dominates the outer solar system. For life on Earth, this was both a danger and a blessing. Jupiter's gravity helped stir up comets and asteroids, sending some crashing into Earth, including the impacts that may have delivered water and organic molecules. But over the long term, Jupiter acts as a cosmic shield. Its immense gravity captures or deflects many of the comets and asteroids that would otherwise bombard Earth endlessly. Without Jupiter's protective presence, life might never have had a chance to survive long enough to flourish. In the grand sweep of cosmic time, Earth's story is a recent development. The planet formed just 4.5 billion years ago. Yet somehow in that short span, conditions coalesced here for life to emerge and thrive. A G-type star, a molten core, a stabilizing moon, abundant water, and a protective gas giant. Each of these elements is necessary and sufficient for making a habitable world. Together, they are a cosmic coincidence of the highest order, a fortunate arrangement that gives us a home and a cradle unlike any other place we know. So let us marvel at the story of Earth, a world sculpted by chance, calibrated for life, and let us treasure it all the more for being so exquisitely rare. The conditions that made Earth habitable are mind-bogglingly specific. There are probably millions of planets out there with similar conditions, but Earth is the only one we know that has life. Why? Is Earth truly unique? Or are there other worlds that share these same traits? 1. Star type and location. Earth is located in the habitable zone of the Milky Way, a band of just-right stars where conditions are suitable for life as we know it. Our Sun is a fourth-generation star, the third-born of its kind in our galaxy. It formed from a stellar nursery of gas and dust, left over from the deaths of its ancestors. Each time a star like our Sun dies, it enriches the galaxy with heavier elements, creating the building blocks for planets and life. If our Sun were any older or younger, life might not exist. Earth would be either too frozen or too hot. But our planet's position is also key. We orbit a star that is relatively small, average in temperature, and not too bright. If our solar system were any closer or farther from the center of the galaxy, we might not have the stable conditions needed for life. 2. The Moon. Sometimes the big questions have small answers. Take the Moon, for example. Its gravity pulls Earth's oceans into giant tides, mixing nutrients and oxygen into the water and distributing them around the globe. This helps support life in the oceans. But the Moon also stabilizes Earth's tilt. Without this, our planet's orbit would be wonky, causing extreme weather and hindering life from evolving and thriving. 3. Liquid water. On most worlds, water exists as ice or vapor, but not on Earth. Our planet is in the Goldilocks zone, where temperatures allow water to naturally exist as a liquid. This makes water a solvent, dissolving more substances than any other liquid and carrying them in its flow. Water is vital for all life we know of. It's a key ingredient in the chemistry of cells and the ecosystem services that sustain us. 4. Plate tectonics. Beneath our feet, Earth's surface is alive. Its crust is broken into shifting plates that slowly move, collide, and recycle material back into the mantle. This constant recycling plays a hidden but vital role in habitability. Volcanoes release carbon dioxide into the atmosphere, while weathering and ocean chemistry pull it back down into rocks. This carbon silicate cycle acts like Earth's thermostat, regulating temperatures over geological timescales. Without plate tectonics, Earth might have become like Mars, geologically frozen, or like Venus, locked in a greenhouse inferno. Instead, it remained dynamic, balancing its climate for billions of years. 5. Atmosphere and oxygen revolution. Finally, we come to Earth's atmosphere. At first, it was a toxic mix of gases unfit for breathing. But as life emerged, microscopic organisms in the oceans, they began releasing oxygen through photosynthesis. Over billions of years, this transformed Earth's atmosphere, paving the way for larger, more complex organisms. The Great Oxidation Event, around 2.4 billion years ago, was one of the most important turning points in our planet's history. Without it, Earth would never have supported animals, forests, or human civilization. From the birth of the sun, to the formation of the moon, to the rise of oceans, atmosphere, and tectonics. Each step was essential in crafting Earth's unique habitability. But while we can identify these key factors, many mysteries remain. Is Earth truly unique? Or could other worlds share these same traits? What do we still not understand about the Goldilocks principle? To answer that, we must explore the unknown frontiers of science, the mysteries that challenge our understanding of life in the cosmos. The Earth hangs in the void of space, a tiny oasis amidst an uncaring universe. For billions of years, this oasis seemed utterly alone until the last few decades. Now we know of thousands of worlds orbiting distant stars, yet Earth remains special. It is the only place we know of that nurtures life. It's the only home to all the wonders of evolution, history, culture, and consciousness. But how did our world become this way? Is our home really unique, or just one example among countless others? To answer these questions, we've explored the tale of Earth's formation, untangling the gravity, collisions, and accretion that formed our world. We've traced the extraordinary events that shaped Earth into a habitable world. But science never stops at what is known. The deeper question remains: is Earth truly unique? Or is it just one example among countless hidden worlds across the galaxy? The Goldilocks principle may explain our own story, but it also pushes us to confront mysteries, scientific puzzles that remain unsolved. 6 great mysteries of the Goldilocks principle. 1. How rare is the habitable zone? The idea of a habitable zone sounds straightforward: the region around a star where liquid water can exist. But as astronomers have discovered thousands of exoplanets, the picture has grown more complicated. Some planets in habitable zones are super-Earths, larger and rockier than our world. Others are mini-Neptunes, too gassy for life as we know it. Even being in the habitable zone doesn't guarantee oceans, atmospheres, or the chemistry of biology. In other words, the Goldilocks zone is necessary, but it may be exceedingly rare for a planet to actually stay just right. 2. The role of cosmic coincidence. Many scientists ask, how much of Earth's habitability is inevitable and how much is luck? Take the moon. Few planets have such a large satellite relative to their size. Was Earth's stabilizing moon a cosmic accident that just happened to benefit life? Or Jupiter, our giant shield? Did its presence make Earth possible? Or is that simply chance? The deeper we look, the more it seems that habitability is not just about physics and chemistry, but also about improbable coincidences stacked on top of each other. This challenges us with the concept of the rare Earth hypothesis, the idea that complex life may be vanishingly rare in the universe. 3. Alternative biochemistries. But what if our definition of Goldilocks is too narrow? We search for Earth-like planets because we assume life requires water, carbon, and oxygen. But what if there are other possibilities? Some scientists speculate that methane or ammonia could serve as solvents for exotic life on colder worlds, such as Saturn's moon Titan. Others suggest silicon-based life might exist under different conditions. If such life exists, then the Goldilocks principle expands dramatically, and many worlds that look uninhabitable to us could actually thrive with forms of life beyond our imagination. 4. The faint young sun paradox. There's also a puzzle about Earth itself. Billions of years ago, the sun was about 30% dimmer than it is today. By simple physics, Earth should have been a frozen ball of ice, yet geological evidence shows liquid water existed. How? This faint young sun paradox remains a mystery. Perhaps Earth's early atmosphere had stronger greenhouse gases. Perhaps volcanic activity or orbital factors provided extra warmth, but the exact mechanism is still unknown. This paradox reminds us that even Earth's own habitability is not fully understood. 5. The great filter question. Even if life emerges on many Goldilocks planets, why don't we see evidence of advanced civilizations in the cosmos? This is the famous Fermi paradox. One unsettling possibility is the concept of the great filter, that somewhere in the chain from chemistry to intelligent life, there is an almost impossible barrier. If Earth managed to pass that barrier, it may mean we are incredibly rare. Or worse, the filter could lie ahead of us, suggesting civilizations tend to self-destruct before spreading to the stars. Either way, the Goldilocks principle intersects with one of humanity's greatest mysteries. Are we alone? 6. Habitability is a moving target. Finally, habitability is not a fixed state. Earth itself will not stay in the Goldilocks zone forever. As the sun ages, it will brighten. In about 1 billion years, Earth's climate will heat to the point where oceans evaporate and life as we know it will vanish. The Goldilocks conditions that nurtured us are temporary, a fleeting window in cosmic time. This means the Goldilocks principle is not just about where a planet is, but when it is. Habitability has an expiration date. So we are left with more questions than answers. How likely is our solar system's configuration? How common are Goldilocks planets in general? Could there be silicon-based life thriving nearby? And what might the faint young sun tell us about Earth's deep past? These questions touch on some of the biggest mysteries in science, and they drive home the awesome responsibility we have towards our own world. As we peer into the darkness searching for answers, we must also care for the one oasis we know supports life. The Goldilocks principle tells us that Earth is special, but it also pushes us to understand what makes us so exceptional, and what we might lose if we don't preserve our planet's delicate balance. Earth's landscapes are full of wonders. Towering mountains, cascading rivers, and sprawling cities, all blending together to form the world we call home. But when we look up at the night sky, we begin to understand that these wonders are more than just scenery. They're a reflection of something far greater, a cosmic balancing act that has given birth to life as we know it. Welcome to my channel. Join me on a journey to explore Earth's remarkable place in the universe and discover why our world is truly a gift from the stars. From Earth's comfortable climate to its protective atmosphere and abundant fresh water, each feature of our planet is the result of an incredible series of events that make life possible. Yet we often take these blessings for granted, failing to appreciate the unique set of circumstances that have allowed humanity to thrive. Let us take a moment to consider the countless ways that our planet's position in space has shaped our world. The Goldilocks principle tells us that Earth occupies a special place in the universe. It's not too hot or too cold, not too close or too far away from the sun. It's just right for life, just like Goldilocks and the Three Bears. Our planet's distance from the sun strikes a delicate balance between scorching temperatures and freezing cold. This Goldilocks zone ensures that Earth is neither too hot nor too cold, creating a perfect environment for life to flourish. But what does this mean for our planet's features? Start with our atmosphere, the thin layer of gases that surrounds Earth. Our atmosphere is essential for life as we know it. It provides the oxygen we need to breathe and protects us from harmful radiation from the sun. The pressure and temperature of Earth's atmosphere are just right for life. Thanks to our planet's ideal distance from the sun, our atmosphere is a habitable environment. This hasn't always been the case. Billions of years ago, Earth's early atmosphere was very different. There was no oxygen, and the temperature was too hot for water to exist in liquid form. However, over time, the composition of the atmosphere changed as microscopic organisms known as cyanobacteria evolved and began producing oxygen as a byproduct of photosynthesis. This process gradually increased the amount of oxygen in the atmosphere until it reached the current level of 21%, which is just right for complex animals like us to breathe. Additionally, the temperature of the atmosphere is also within the habitable range, thanks to the ideal distance from the sun. If Earth were closer to the sun, the atmosphere would be too hot and water would evaporate. If Earth were farther away, the atmosphere would be too cold and water would freeze. Next, let's talk about Earth's climate. The average temperature on Earth is about 15 degrees Celsius, which is just right for life to thrive. This is due to the planet's ideal distance from the sun and its tilt on its axis. The tilt causes the Earth's orbit to change throughout the year, resulting in seasons and a distribution of heat around the globe. This keeps Earth's climate within the habitable range and makes it suitable for life. Without this balance, Earth would either be too hot or too cold for life to flourish. Another important aspect of Earth's climate is the amount of precipitation. The planet receives about 1 meter of rain per year, which is just enough to support life. If Earth were closer to the sun, there would be more evaporation and more rain, leading to a water surplus. If Earth were farther away, there would be less rain, resulting in a water shortage. Now let's turn our attention to Earth's water. About 71% of the planet's surface is covered in water, and most of it is in the form of oceans. This is crucial for life as we know it, as water is essential for all living things. The ideal distance of Earth from the Sun ensures that water remains in liquid form and that the temperature is suitable for life to thrive. Oceans also help regulate Earth's climate by absorbing heat and distributing it around the globe. They also play a key role in the water cycle, which distributes fresh water around the planet. Another important aspect of Earth's water is the salinity of the oceans. The amount of salt in the ocean is just right for life. If there were too much salt, it would be difficult for living things to survive. If there were too little salt, the water would be too pure and could easily evaporate. Moving on, let's discuss Earth's land. The planet's surface is about 29% land, which is just enough to support life. If there were too much land, there wouldn't be enough water to sustain life. If there were too little land, it would be difficult for plants to grow and provide food for animals. Finally, let's talk about Earth's magnetic field. This invisible force protects the planet from harmful radiation from the sun. Without this shield, the atmosphere would be stripped away and Earth would be left exposed to deadly radiation. So as we can see, Earth's features are the result of a delicate balance of factors that make life possible. From the atmosphere to the climate, water, land, and magnetic field, each aspect of our planet is just right for life to thrive. But it's not just the physical features of Earth that are perfectly suited for life. The chemical composition of the planet is also just right. Earth is mostly made up of oxygen, silicon, aluminum, iron, and calcium. This unique combination of elements creates a diverse range of minerals and compounds that are essential for life. For example, water, which is made up of hydrogen and oxygen, is a critical component for all living things. Carbon, which is found in rocks and soil, is the basis of organic molecules, such as carbohydrates, proteins, and DNA. Furthermore, Earth's position in the solar system provides the necessary conditions for these chemicals to interact and form the complex molecules that are essential for life. For example, the moderate temperature on Earth allows for the formation of water in liquid form, which is necessary for many chemical reactions to occur. The abundance of oxygen in the atmosphere makes it possible for plants to perform photosynthesis, which is the basis of most food chains. However, it's important to note that Earth's Goldilocks conditions are fragile and can be easily disrupted. Human activities such as burning fossil fuels have altered the composition of the atmosphere and are causing climate change. This poses a threat to the delicate balance of factors that make life possible on Earth. It's crucial that we understand the importance of preserving these conditions to ensure the continued habitability of our planet. In conclusion, Earth's features are perfectly suited for life as we know it. From its physical features such as the atmosphere, climate, water, land, and magnetic field to its chemical composition, everything is just right for life to thrive. But it's important to remember that these conditions are fragile and require careful stewardship to preserve. By understanding the delicate balance of factors that make Earth habitable, we can appreciate the uniqueness of our planet and the importance of protecting it for future generations. Thank you for joining me on this journey of discovery. Till next time, keep looking up and exploring the wonders of our universe. For most of human history, Earth was seen not as a planet, but as the world, the only one. The sun, moon, and stars were lights in the sky, circling us. The idea that Earth might be one planet among many in a vast universe was unthinkable. Over centuries, human curiosity dismantled that illusion. The Goldilocks principle, our modern understanding of planetary habitability, is the product of generations of observation, struggle, and discovery. No. One ancient insights. Earth as a sphere. In the ancient world, philosophers like Aristotle and Eratosthenes began to realize that Earth was round. By measuring shadows and observing the horizon, Eratosthenes even calculated Earth's circumference with remarkable accuracy. Though they had no concept of habitable zones, their work set the stage by proving Earth was not the center of everything, but one body in a vast cosmos. Number 2. The Copernican Revolution. Earth as a planet. For 2,000 years, the dominant belief was geocentrism. Earth at the center, everything orbiting us. That changed in the 16th century when Nicolaus Copernicus proposed heliocentrism, The radical idea that Earth orbits the sun. This was not just astronomy, it was a philosophical earthquake. Suddenly, Earth was no longer the center, but one planet in a cosmic system. Galileo Galilei soon confirmed this with his telescope, observing the moons of Jupiter and the phases of Venus. His discoveries showed that other worlds, too, were real places, perhaps with their own conditions. Number 3, Kepler, Newton, and the laws of the heavens. Johannes Kepler revealed that planets move in ellipses, not circles, governed by mathematical precision. Isaac Newton later explained this motion through gravity. These discoveries transformed the heavens from a mystical realm into a system of natural laws. Earth was not special in its mechanics. It obeyed the same rules as every other planet. This realization paved the way for thinking scientifically about why Earth was different, not because of supernatural privilege, because of natural conditions. And now we have sent spacecraft to drift above our home, revealing the fine details of its beauty and its fragility. We have found that within our own solar system, conditions for life as we know it seem to be surprisingly rare. Water, a substance essential for life as we know it, is a rare find. And Earth's distance from the sun, keeping it within the habitable zone where liquid water can exist, is also unusual. Our solar system seems to be a mild outlier, not a typical example of planetary systems elsewhere in the Milky Way. The exoplanet Kepler 442b orbits a star, much like our Sun, but it is in the habitable zone of its star, though it may be tidally locked, meaning one side perpetually faces its star, while the other remains in darkness. Could there still be life on the side of the planet that experiences eternal night? Or does life need both darkness and light? We do not know. In the quest to understand our place in the universe, we have come a long way from the Earth-centered view of the cosmos. As Alan Stern, principal investigator of NASA's New Horizons mission to Pluto, and Harold Levison have written, Earth is a very special planet because that's the one we live on, but it is not unique. There are probably billions of other rocky planets out there that could support life, or maybe even do so right now. Our journey of discovery has just begun. The Goldilocks principle is named after the children's story about a girl who tests her family's chairs until she finds one that is just right. In the same way, the habitable zone around a star is the range of distances from the star where conditions could be just right for life as we know it. But there are many kinds of stars and many kinds of planets, and the concept of the habitable zone is just one piece of a very big puzzle. Scientists are learning more about the building blocks of life, the conditions that might allow life to arise, and the amazing variety of worlds out there. They are asking, what might life need to thrive? What are the ingredients for life? And how common or rare are they? Our search for life beyond Earth is guided by the knowledge that we are all made of stardust. The atoms that make up our bodies were forged in the cores of stars. We are literally connected to the evolution of the universe itself. Yet despite our deep connection to the cosmos, we tend to think of ourselves as unique, special, perhaps even alone. But as we continue to explore the universe, we are finding that Earth is not so unique after all. Our solar system is just one of billions in the Milky Way. Other systems may have planets that are similar to Earth. They may have planets that are even better suited for life than ours. And if we can find those planets, we may find signs of life. We may even find ourselves on the verge of making first contact. Images and footage courtesy of NASA. Once upon a time, there was a girl who climbed up her father's bed to peek out the window. She was looking for her dog who had run away. Instead, she found a bear. Now, most Goldilocks stories end there, but let me tell you what happens next. Goldilocks tests the strength of the bed 3 times. First, she gives it a little jiggle. Then she bounces up and down a little more vigorously. Finally, she jumps with all her might. Each time, the bed gets a little weaker until finally it breaks under her weight. See, Goldilocks is too tough for the bed, just like our world is too tough for the Goldilocks principle. You see, the Goldilocks principle states that things need to be just right for life to emerge and thrive. Goldilocks and her bed illustrate this perfectly. Not too hard, not too soft, just right. Our world is just right for life. We live in the Goldilocks galaxy at the Goldilocks moment, an astronomically lucky place and time for life to emerge. But how do we know that our world is so special? Well, let's start at the beginning. 4. The birth of astrobiology. Searching for life elsewhere in the 20th century. As we learned more about planets, scientists began asking whether Earth's habitability was unique. Astronomers discovered the harsh realities of Venus and Mars, worlds that shared similarities with Earth, yet turned out inhospitable. This sharpened the idea that habitability required a delicate balance, a Goldilocks condition. Meanwhile, biologists uncovered the story of life's origins on Earth. Experiments like the Miller-Urey test in 1953 showed that simple organic molecules could form under early Earth-like conditions. The line between chemistry and biology began to blur. Next, humanity left Earth. 5. The Space Age. Seeing Earth from afar, when humans launched satellites and spacecraft, we saw Earth as never before. The famous blue marble photograph taken by Apollo 17 in 1972 revealed Earth's fragility, a small, vibrant world in the darkness of space. These images redefined our perspective. Earth was not infinite, not indestructible. It was a singular oasis. Space probes like Voyager, Galileo, and Cassini revealed the diversity of other worlds: gas giants, icy moons, volcanic landscapes, emphasizing how rare Earth's balance is. But we still didn't know how rare. 6. The exoplanet revolution, the true explosion of the Goldilocks principle, came in the last 3 decades. With missions like NASA's Kepler Space Telescope, TESS, and ESA's Cheops, astronomers have confirmed thousands of exoplanets orbiting other stars. Some are in their star's habitable zone. Others are gas giants, or scorched wastelands, or frozen worlds. We now know that planets are common, but habitable ones remain uncertain. Every discovery sharpens the question: how many Earth-like worlds exist? Are we rare or typical? Today we have the tools to find out. 7. Today's tools: searching for Earth's twins. Modern observatories like the James Webb Space Telescope are now scanning the atmospheres of exoplanets, looking for biosignatures, gases like oxygen, methane, or water vapor. For the first time, humanity has the tools to search directly for signs of life on other worlds. In doing so, we are testing the Goldilocks principle against the universe itself. What we discover could either affirm Earth's uniqueness or reveal that the cosmos is teeming with life. Narrator. The Goldilocks principle is not just a story of cosmic luck. It is the story of discovery, of human beings slowly realizing that we inhabit a rare, fragile world. But what comes next? What are the future implications of this knowledge? How might it change our understanding of life, the universe, and our place within it? Visuals: futuristic telescopes, spacecraft, humans gazing into star-filled skies. Earth rises above the horizon of the moon. Cutting to an array of futuristic telescopes scanning the night sky, searching for life beyond our world. A lone starship flies through a field of alien plants on an uncharted planet, discovering remnants of a long-lost civilization. As the ship departs, the camera pans across an endless expanse of galaxies filled with trillions of planets. Hinting at the countless worlds that could be out there, a voice echoes through the vastness of space. Imagine standing on the surface of the moon watching Earth rise above the lunar horizon. You looking back at home through the eyes of every creature that has ever lived on this planet. Their story is written in the dust that covers your boots, in the footprints you're about to leave behind. From the very first single cell to the largest animal, every living thing has depended on the story that Earth tells. There is no guarantee that such a story would ever repeat itself. But here you are breathing the thin lunar air, aware that your own story is only possible because of a series of events so delicate, so improbable that if any piece had fallen into place, even slightly differently, you wouldn't be here at all. Earth viewed from space, spinning slowly against the backdrop of infinite darkness. Cut to scientists analyzing data, searching for signs of life beyond our planet. This realization isn't a new one. For millennia, humans have marveled at their good fortune. The ancient Greeks spoke of Earth as the happy planet. The Romans referred to it as the fertile one. Throughout history, people have prayed to whatever gods they believed in to preserve it. But now we understand the precarious nature of our existence on Earth a little better. We know that each step in the chain of events that led to our being here was almost certainly doomed to failure at almost any point in time. Take away any piece and the others fall apart. That makes our existence on this planet nothing less than miraculous. We owe our existence to a cosmic game of chance. If the conditions that led to Earth were different, we simply wouldn't be here. This is the Goldilocks principle at work. Named after the famous children's story of Goldilocks and the Three Bears, the principle states that conditions must be just right for life to flourish. Take temperature, for example. If Earth were closer to the sun, it would be too hot. Further away, it would be too cold. If there was too much or too little gravity, oceans wouldn't exist. Without the sun's radiation, photosynthesis wouldn't be possible. Without a protective atmosphere, Earth would either freeze or boil. I think these examples go on, and it's likely that many other conditions could doom us as well. Earth's tilt axis, for instance, is remarkably stable, which allows us to have seasons. But even a slight wobble could send our climate into chaos. Taken together, these conditions form a Goldilocks zone, a narrow range in which conditions are just right for life to develop and thrive. Each factor in this equation can be represented as a line on a graph, and the intersection of those lines represents the Goldilocks zone. And as long as Earth stays within this zone, life should continue to flourish. But as we watch our universe unfold over billions of years, this zone begins to shrink. First, the sun grows brighter, shifting our world out of the habitable zone. Later, the Earth itself begins to cool, and eventually our planet freezes over. The universe doesn't care about us, and billions of years from now, Earth will be just another dead rock floating through space. All life on our planet will vanish, leaving behind a lifeless husk of what once was a cradle of life. The Goldilocks principle implies that Earth is our only hope for life. If the conditions needed for life are so delicate, so unlikely to occur again, then we may truly be alone in the universe. But that doesn't have to be the case. Life might be very common throughout the universe. Earth might simply be one of billions of planets where life finds a way to flourish. This view is supported by the sheer number of planets out there in the Milky Way. NASA believes there could be as many as 100 billion planets that could support life. Maybe life on Earth is anything but remarkable. We've just happened to stumble upon the only known example in our region of space. After all, life on Earth didn't happen overnight. It evolved over billions of years. It was only after hundreds of millions of years of evolution that the first complex organisms appeared. And it wasn't until another 500 million years after that life began to flourish. Over the eons, the Goldilocks zone shifts as Earth changes. But as long as life finds a way to adapt, it should continue to survive. For example, as the sun gets bigger, Earth will eventually drift out of its habitable zone. At that point, life on Earth would have to migrate elsewhere, maybe to Mars or to a moon or perhaps to a whole new system of planets. But as long as life persists, the Goldilocks principle suggests that it will always find a way to survive. The fact that life has flourished on Earth for so long is reason enough to think that it could continue to do so for billions more years. Even if our current civilization collapses due to our own doing, life itself shouldn't end. Bacteria, fungi, and other organisms have proven themselves capable of thriving in nearly every environment on Earth. And chances are that some form of life will persist for the foreseeable future, evolving and adapting, until conditions become too harsh to support it. The Goldilocks principle reminds us that life on Earth is not guaranteed. It is the result of cosmic balances. Balances that could have tipped differently at any stage in our history. But now that humanity understands this delicate equation, we face new questions. What does this knowledge mean for our future? What comes next? Our story so far has been one of a constant search for a place to call home. Since we left Africa, we've pushed across continents, searching for somewhere new, somewhere better. But Earth is our only home. It is the only place we know that can sustain life. And yet, for all our ingenuity, we are still bound to it. The Goldilocks principle tells us that we cannot escape this fate. No matter where we go in the universe, we will always need a place to land. Perhaps the most direct implication is our ongoing search for life elsewhere. Every exoplanet we discover, every icy moon we explore, tests the Goldilocks principle. If we find microbial life on Mars, Europa, or Enceladus, it would mean that habitability is not as rare as we fear. If we discover biosignatures on distant exoplanets, it could reshape our understanding of biology, showing that the universe is not silent, but alive. But if the cosmos remains quiet, then Earth may be truly extraordinary, a responsibility as much as a gift. We need only look around us to see the fragility of the systems that make life possible. While Earth has maintained its just right conditions for billions of years, we have the power to alter them within a few centuries. Just as Goldilocks unwittingly threatened the stability of the bear's home, we too can tip the scales of life on Earth. Climate change, habitat destruction, and atmospheric pollution threaten the very systems that make this planet habitable. But unlike Goldilocks, we are fully aware of the consequences of our actions. Protecting Earth is not an option, it is survival. The Goldilocks principle tells us that our survival is not guaranteed. It is the result of a cosmic game of chance. Each factor that makes life possible is a cosmic coin toss. And if any of these factors had fallen differently, we wouldn't be here. We are the product of an incredible series of coincidences. Our very existence is nothing short of miraculous. And yet we take it for granted every day. But as the Goldilocks zone shrinks and the future of our planet hangs in the balance, we are reminded of how precious our home really is. The Goldilocks principle is a humbling experience. It forces us to confront the reality of our existence. We are the product of chance, layered on chance. Cosmic lottery win. The question is, what will we do with it? Earth seen from deep space, a glowing blue marble fading into the darkness. The Goldilocks principle shows us that Earth is precious, rare, and finite. It is the only home we know, a fragile balance in an unforgiving cosmos. The more we learn about the universe, the more extraordinary our world becomes. And as we gaze into the stars, one truth becomes clear. We live on the planet that won the cosmic lottery. The real question is, will we be wise enough to keep it? Fade to black. End credits. Thank you for watching this C-Show video.